Clearly, SpaceX's Starship is facing challenges with its heat shield, particularly the heat-dissipating tiles that protect it during reentry. However, with Elon Musk's determined attitude, he certainly won't let this hinder his ambitions. Recently, Elon Musk revealed impressive technical solutions to address the heat shield issue. Let's find out on today's episode of Alpha Tech. How did Elon Musk's SpaceX fix the Starship heat shield in reentry? In engineering, a heat shield is a component designed to protect an object or operator from burning or overheating by dissipating, reflecting, or absorbing heat. Therefore, no spacecraft can re-enter Earth's atmosphere without a heat shield. It is also a crucial component of SpaceX and Elon Musk's ambition of fully reusable rockets. With the impressive performance in the fourth launch, we observed instability with the heat shields, specifically a weak point between the flap and the main body of the Starship. This vulnerability nearly compromised the spacecraft, as the intense heat during the re-entry caused considerable damage to the flap. Despite this, Starship remarkably managed to complete its landing burn with the flap still functioning, demonstrating the spacecraft's robust design and resilience. But not to keep us worried about the issue of heat shields for long, SpaceX and Elon Musk have been striving to improve the heat shield landing capabilities of their reusable Starship. And indeed, they are being carried out right on Ship 30 in preparation for the launch of Starship Flight 5. The first solution proposed by SpaceX and Elon Musk is to replace the entire heat shield with new tiles that are twice as durable as the previous ones. We're going to replace the whole heat shield on the ship, so the new heat shield tile is about twice as strong as the ones that were on the last flight, shared Musk. The new tiles are about twice as strong, or hopefully half as likely to crack or come off. If during the fourth flight, the Starship's heat shield could withstand external temperatures of up to 2,600 degrees Fahrenheit, 1,430 degrees Celsius, which is hot enough to melt aluminum, a metal used in the structure of many launch vehicles, the new heat shield will withstand temperatures of up to 5,200 degrees Fahrenheit, 2,860 degrees Celsius. That is a massive number. This, combined with the heat shield's excellent hexagonal shape without straight lines for hot gases to accelerate through gaps, will enhance its durability against extreme temperatures when re-entering the atmosphere. By addressing the weakness observed in the recent flight, the company is striving to make Starship a more reliable and safer vehicle for future missions, including those carrying human passengers. Next, Elon has revealed that SpaceX plans to add an abrasive layer beneath the heat shield tiles. This new layer is designed to act as a secondary line of defense, providing additional protection in case the main tiles crack or fall off during launch or re-entry. Adding this abrasive material is a strategic move to prevent catastrophic failure and ensure the structural integrity of the spacecraft under extreme conditions. Ablative materials are designed to slowly burn away in a controlled manner when exposed to the intense heat of atmospheric re-entry. This ablation process absorbs a tremendous amount of heat energy through the material's phase change. Adding this sacrificial ablative layer underneath the primary heat shield tiles can provide an extra level of thermal protection during the demanding re-entry environment Starship will experience when returning from orbit. The ablative material chars and burns away, but in doing so, it insulates and protects the heat shield tiles and vehicle structure from the most extreme heating. Some specifics on the ablative material SpaceX plans to use have not yet been made public. However, Elon Musk has said that this material is like a silicon felt ablative, which is not good for reuse, but keeps the ship and its inhabitants safe in case the tiles fall off during or before re-entry. The addition of this ablative layer aims to increase the overall heat production capabilities of Starship, potentially allowing for higher re-entry speeds and heating conditions that the heat shield tiles alone could withstand reliably over many uses. And surprisingly, Elon Musk has thought of this measure beforehand. He said that SpaceX tested this secondary abrasive material during the fourth flight in areas where the heat shield tiles were deliberately removed. Simple, yet extremely important. There were 2 empty slots without heat shield tiles on Ship 29. So, why did SpaceX take such a risk? Didn't Elon Musk previously warn that missing just one tile would cause the Starship to explode? Yes, it was an experiment. SpaceX eventually stated that these experiments were deliberately conducted to test whether or not a missing tile would indeed be a mission-ending scenario. The location of these tiles is also noteworthy. They are in critical areas such as the ship's engine margins. If the steel did indeed melt, causing any engine-related systems to fail, it would impact the Starship's positioning. Additionally, next to these 2 empty places, there was another tile that appeared thinner than the others. We can also notice this when looking at zoomed images. Of course, this was another test by Starship with a thinner and lighter test shield. The trend of this test focuses on the potential to reduce the overall weight of the spacecraft. This may appear in future prototypes. The possibility that this tile merely appears thinner could be due to the insulation foam layer beneath the tile being removed. This layer lies between the bare stainless steel and the tile to provide insulation during reentry. Moreover, a thinner heat shield also facilitates the integration of the secondary abrasive material into the spacecraft later on. To be honest, this comprehensive redesign of the heat shield is a key component of SpaceX's strategy to achieve rapid reusability for Starship. By increasing the strength and reliability of the heat shield, the company aims to reduce the need for extensive repairs and maintenance between flights. This not only enhances the safety of the spacecraft, especially for missions carrying human passengers, but also aligns with SpaceX's broader goal of making space travel more cost-effective and sustainable. There are certainly many exciting things we are waiting to see for future Starships. However, SpaceX must implement these changes to know their effectiveness. SpaceX has not yet announced the results of the 2 heat shield mini-tests, but we all know that SpaceX is clearly identifying the best way to make modifications. Notably, these new modifications were immediately implemented on Ship 30 for the Starship Flight 5. On June 11th, we saw the first activity of dismantling the heat shields from the nose cone of the spacecraft. In the upcoming days, SpaceX will remove and then reinstall the new heat shield tiles. It's worth looking forward to seeing the results of this change. So, what do you think about this issue? Please comment and let us know your thoughts. By the way, if you haven't subscribed to our channel yet, we humbly ask that you give us a like and subscribe. That's a huge motivation for us to keep putting out more quality videos for you to watch. Indeed, the aforementioned issues with Starship's heat shield need to be put into practice to see how complex they truly are. But did you know that even before the heat shield was tested, it posed many challenges that SpaceX struggled with? The re-entry phase of a spacecraft's journey is one of the most technically challenging aspects, particularly regarding the heat shield's performance. SpaceX's uses of ceramic tiles for Starship's heat shield presents several significant challenges. Ceramics, while excellent at withstanding high temperatures, are inherently brittle. This brittleness makes the tiles susceptible to cracking and breaking under the mechanical stresses experienced during launch and re-entry. One of the primary issues with ceramic tiles is their tendency to expand and contract due to temperature changes. During launch, the rocket experiences intense vibrations and mechanical stress, causing the structure to expand and contract. As the spacecraft reaches space and encounters extreme cold followed by the searing heat of re-entry, the ceramic tiles undergo substantial thermal expansion and contraction. Keeping these tiles intact and properly adhere to the spacecraft under these conditions is a formidable engineering challenge. The situation is reminiscent of the Space Shuttle's heat shield, which also used ceramic tiles. The shuttle's tiles required meticulous inspection and often extensive repair after each flight, significantly extending the turnaround time between missions. The repair process was labor-intensive and costly, as each tile had to be carefully checked and replaced if damaged. SpaceX aims to overcome these challenges by not only improving the strength of the tiles, but also by integrating a secondary protective layer of ablative material. This dual-layer approach provides a backup in case of tile failure, absorbing and dissipating heat to prevent catastrophic damage to the spacecraft. By learning from the Space Shuttle's experiences and advancing heat shield technology, SpaceX is working towards a more robust and reusable system. This is crucial for the company's goal of rapid reusability, reducing the needs for extensive post-flight repairs and enabling quicker turnaround times for Starship missions. Elon Musk just declared that Starship is the most powerful flying object ever created. With 6 Raptors for Starship and 33 for Super Heavy, the current thrust of Starship is already more than twice that of Saturn V. However, in reality, Starship can be even more powerful than that. With future upgrades, Elon Musk mentioned it would have 3 times the thrust. And coincidentally, in a recent report by SpaceX, they inadvertently revealed details about adding new engines for Starship and Super Heavy. How many more Raptor engines SpaceX will add to Starship? Is this the final rocket variant that SpaceX intends to use long-term for all their space exploration missions? According to the new details that SpaceX disclosed in the proposed environmental review for the FAA, the upgraded version of Starship will include 35 Raptor engines for the Super Heavy booster and 9 engines for the upper stage. Focusing on the 9 Raptor engines on the Starship upper stage, we can infer that this version is likely Starship V3. This is based on an image Elon shared in April, which shows that only the second stage of Starship V3 has 9 Raptor engines. From this, we can conclude that the final version of the rocket that SpaceX will develop is Starship V3, with a Super Heavy booster equipped with 35 Raptor engines, a point that many space enthusiasts have been curious about since SpaceX revealed the new Starship variants. In the past, SpaceX has considered various numbers of engines for the Super Heavy booster for larger versions of Starship. Back in 2019, SpaceX proposed that the Starship rocket would have a Super Heavy booster with 31 Raptor engines, later increasing to 35, then 37, and even up to 41 engines at one point. However, due to the design of Raptor's engine and the arrangement needed to properly distribute thrust for the Super Heavy's operation, SpaceX and Elon Musk eventually decided on 33 engines, with a maximum of 35 per booster. With 35 engines and 10,000 tons of thrust, the Super Heavy V3 will use Raptor 3 engines, each providing more than 280 tons of thrust. This specification aligns perfectly with all the slides about the rocket variants and engine types we've studied before. To compare, the thrust of Super Heavy V3 alone is 3 times that of the legendary Saturn V. The height of Super Heavy by itself is 80.2 meters or 263 feet. Equivalent to a 30-story building and 60 feet taller than the Statue of Liberty. It is indeed the largest rocket booster in the world. Having said that, we must also not overlook the second stage, sitting atop Super Heavy, which is a spacecraft playing a crucial role in achieving the dream of breaking through Earth's sky. An optimal 9-engine Starship tank would be stretched about 25% to store an additional 300 tons of cryogenic liquid oxygen and methane, LOX-LCH4. That upgraded Starship would have a liftoff mass close to 1,600 tons and stand about 70 meters tall, 40% taller than current ships. At stage separation close to vacuum, a stretched Starship with 3 sea-level optimized Raptors and 6 vacuum-optimized Raptors should produce at least 2,700 tons of thrust, and possibly more depending on engine performance. Regardless of its thrust, dimensions, or weight, what matters most is how a stretched 9-engine Starship would impact that overall rocket's launch performance. If unofficial modelers are to be believed, the results are significant. Compared to a normal Starship with a 6-engine upper stage and 33-engine booster, the stretch ship could theoretically boost the amount of payload the rocket can launch to low Earth orbit from about 150 tons to over 200 tons or more. That's almost a 50% improvement. If those estimates are accurate, upgrading Starship by adding 9 Raptor engines and enlarging its fuel tank is the obvious choice. While this might delay development and increase the cost of each 9-engine ship, the potential 50% boost in payload capacity would greatly enhance the efficiency of Starship's missions to the Moon and Mars, which needs several refueling stops on the way. All these advantages demonstrate that a larger and longer version of Starship, which SpaceX aims to build, is an obvious reality. As the company strives for new developments to achieve optimal results in its work, this is something that any company in any industry would want to learn from. This is why we see SpaceX repeatedly conducting tests that might end in explosions. Ultimately, these are not failures, but successes and victories over their own challenges, a rocket manufacturing approach vastly different from traditional companies. Similar to the number of engines on Starship, SpaceX has chosen its own unique path. Instead of opting for larger rocket engines, they have decided to install a greater number of smaller engines. When it comes to reusable rockets, there's a very specific reason to have smaller rocket motors, and it's quite surprising. Getting less thrust from rocket motors is incredibly difficult. Rocket motors cannot operate below a certain minimum amount of thrust. If you try to cut the thrust too much, they'll suddenly cut out altogether. Consider Starship, which weighs about 100 tons but requires 1,200 tons of propellant, liquid methane, and liquid oxygen for launch. During liftoff, the rockets must accelerate 1,300 tons to high speeds. However, during reentry, almost all of that fuel is gone, leaving only a few tons of propellant, reducing the overall weight to about 1/10 of what it was at launch. Imagine you have one giant motor capable of running between 20% and 100% thrust. But below 20%, it stalls. If it has enough thrust to launch 1,300 tons, the least thrust it can provide during landing is 20% of that, or 260 tons. This much thrust would cause the rocket to launch back upwards instead of allowing a gentle landing. Now, consider having 4 rocket motors, each capable of providing a quarter of the 1,300 tons of thrust required for launch, 425 tons each. During landing, instead of throttling each motor down to 10% power, You can shut off 3 motors and run the last one at a comfortable 40% thrust, allowing for a controlled descent. Even with the Falcon 9's 9 Merlin engines, operating just one at a minimum thrust makes hovering impossible. Instead, it has to perform a suicide burn or hover slam landing, reigniting the engine at the last possible moment to slow down rapidly and cut the engine precisely as it reaches zero altitude and speed. A terrifying maneuver requiring perfect timing. The Raptor engine can throttle down to a lower thrust than the Merlin, but landing remains a technological nightmare. Having multiple motors provides redundancy. If one fails, the others can still provide enough thrust for a safe landing. For Starship, additional complications arise when landing on Mars. 38% of Earth's gravity, or the Moon, 16% of Earth's gravity, requiring even lower thrust levels. SpaceX plans to mass-produce thousands of Starships and hundreds of Super Heavy boosters, requiring tens of thousands of Raptor engines, an unprecedented quantity for rocket motors. 3D printing techniques allow for cost-effective mass production, and having a large number of smaller motors simplifies the manufacturing process compared to fewer, larger motors. So, why hasn't this been done before? To be honest, this was already done long ago by the Soviet Union when they built the N-1 rocket with 30 engines. But as Pablo de Leon, the chair of the Department of Space Studies at the University of North Dakota, puts it, it's a nightmare for the plumbers, reminiscent of the Soviet Union's 30-engine N-1 moon rocket, which was intended to carry cosmonauts to the moon, but it's best remembered for blowing up spectacularly in the 1969 test flight, causing the largest explosion in space history. The Soviet N-1 erupted just seconds after liftoff, collapsing back to the ground and destroying the launch pad. In contrast, SpaceX has successfully launched 4 times, with 3 of those launches seeing all 33 engines doing well on the flight. This track record gives confidence that even with an increase to 35 engines, SpaceX is likely to maintain its success. Now the company is continuing to build new Starships at a furious pace, reminiscent of NASA's Apollo era when 13 Saturn V's were flown from 1967 to 1973, 9 of which carried crews to the moon in just a 4-year window. I think they have a long factory full of multiple duplicates of these systems, says Logsdon. It's not like they lost something that's irreplaceable. Musk has delivered on his promises for Starship, although the timeline may have been delayed. The company has staked its future, and NASA has staked its Artemis moon program on the promise that the Mammoth rocket will indeed fly and fly well.
Next launch, Starship launches probably in about a month.
Oh my goodness, what an incredible speed. 7 months, 4 months, and 2 months are the intervals between Starship test flights, and they're getting shorter. And this time is no exception. The waiting time for the 5th Starship flight will be ready in just 1 more month. So why are Elon and SpaceX turning around Starship launches with speed so fast? What can we expect in Flight 5, and how many changes has Elon upgraded on the next launch? In 2023, the first test flight of Starship caused significant damage to the launch pad and discovered numerous technical details that needed refinement related to the Starship rocket, which required SpaceX a lot of time to fix and address. This led to extended delays till the second flight. However, living up to its reputation as the king in the space race, by the 4th Starship launch, SpaceX had cut that wait time by more than half. Now, with most of the issues with the launch pad and rocket resolved, SpaceX can quickly conduct more test flights to improve technology and gather data. And Elon Musk believes that the 5th Starship test flight will take place in a month. So, how will Elon Musk and SpaceX prepare for this early launch? During the live broadcast on X, in addition to revealing the new launch schedule for Flight 5, Elon also shared new upgrades for the massive spacecraft to increase the chances of success for not only the upcoming flight, but also for future missions. First, an important change SpaceX needs to make is to Starship's heat shield. As is the case with other spacecraft, Starship's heat shield is one of the most complex components. SpaceX uses 18,000 hexagonal ceramic tiles, similar to the heat-absorbing tiles used on NASA's space shuttles. During re-entry, the temperature outside the rocket can reach up to 2,600 degrees Fahrenheit, that's 1,430 degrees Celsius, hot enough to melt aluminum, a metal used in the structure of many launch vehicles. According to Musk, before the next flight, SpaceX will upgrade the rocket's heat shield tiles. This was confirmed by Elon on X when he responded to everyday astronauts' tweet about the heat shield. Not a difficult prediction. We will have this nailed for the next flight. One regular problem that Starship has faced throughout its testing history is the heat shield tiles falling off. These tiles come loose during flight and while the rocket's on the ground. Musk shared that SpaceX plans to add an additional layer under the tiles to keep the ship safe during re-entry in case its tiles start to fall off. We're going to replace the whole heat shield on the ship. So the new heat shield tile is about twice as strong as the ones that were on the last flight, shared Musk. And we want to put an ablative secondary structure, like basically ablative protection behind the tiles, so that if a tile cracks or come loose, it doesn't cook the rocket, he added. The new tiles are about twice as strong, or hopefully half as likely to crack or come off, and SpaceX tested the secondary ablative material in the fourth flight in the areas where the heat shield tiles were deliberately removed. This material is like a silicone, felt ablative, which is not good for reuse, but keeps the ship and its inhabitants safe in case the tiles fall off during or before reentry. In addition to the heat shield, the hardware of Starship also needs to be reviewed again and upgraded by SpaceX. Notably, the hot staging section located above the Super Heavy plays a crucial role in assisting the separation of the two rocket stages. During the fourth flight, SpaceX jettisoned the hot staging to reduce the weight of Booster 11 as it returned to Earth. However, it is known that this was only a temporary measure used for this launch, as continuously discarding the hot staging would reduce Starship's quick turnaround capability. Therefore, the trend toward designing a new hot staging is extremely positive for Starship. With a new design, discarding the hot staging will no longer be necessary. Another system expected to be upgraded on Starship is the addition of roll control thrusters. This improvement will help SpaceX better control the landing process and attitude, minimizing those issues like valve clogging that occurred during Flight 3. SpaceX has stated that they've implemented this upgrade since prototype Ship 29, and after the success of Flight 4, they will certainly continue to integrate and improve this system in subsequent prototypes to achieve the best results for Starship. Regarding the booster, SpaceX needs to continue improving its engines. In previous upgrades, SpaceX focused on eliminating or simplifying complex and failure-prone components like wiring and nozzles, making the engines more efficient with each flight. However, the necessary reliability has not yet been achieved, as demonstrated by the fourth Starship launch when Super Heavy lost two engines that failed to ignite during ascent and landing. Although this did not affect the success of the flight, I'm sure SpaceX is going to do everything possible to prevent these issues from happening. They'll further enhance their engines, not only in terms of stable operations, but also greater power. As we know, upgrading engines is an ongoing process, applicable not just to a specific version, but to the entire Raptor engine system. From Raptor 1 to 2 and Raptor 3 and even beyond, small details will gradually be minimized. Some may maybe even be eliminated, simplified, or integrated together. These optimizations will significantly reduce operational risks, repair, and production times, while continually increasing engine power. Additionally, SpaceX needs to upgrade the internal systems of the vehicle. Specifically, to address the issue from Flight 3, SpaceX stated the failure of Booster 10's engine was due to a clogged filter, obstructing the liquid oxygen path from the fuel tank to the engine, leading to a loss of input pressure in the oxygen turbopump engine. SpaceX upgraded the fuel filter inside the liquid oxygen tank to resolve this issue, starting from Booster 11 and subsequent prototypes. To enhance reliability, especially after the recent engine failure on Booster 11, they'll continue to closely monitor and strengthen these upgrades. Finally, a change that Elon himself has acknowledged is the re-entry profile of the Super Heavy Booster 12. After successfully landing both stages in the ocean, SpaceX now aims to land using the Mechazilla arm starting from Flight 5, beginning with Super Heavy Booster 12. With comprehensive plans to upgrade the engines and hot staging system, along with the proven landing capability from recent flights, SpaceX is extremely determined to validate the effectiveness of this new landing method, a feat no other organization has achieved before. As Elon revealed in a live stream, he estimates a 50% chance of Mechazilla catching the rocket. Elaborating on the booster's return profile, he revealed that when the booster will come back, it'll have an impact point that's out to sea. So it'll have to steer itself towards the tower with the catch arms, and if the booster detects that anything's wrong, it'll suicide itself into the ocean. If things are looking good, it'll steer over to the tower and the arm should be able to grab it. This means the catch tower performance could happen or not depending on the booster's flight situation. The vehicle can adjust its trajectory and ensure the safety of the launch tower if it encounters any issues. Amazingly, such automatic features are integrated into rocket vehicles. As for Ship 30, the partner of Booster 12, it will once again splash down into the ocean. Promised upgrades to the heat shield and nose cone will significantly increase the chances of Ship 30 surviving re-entry intact. This will lay the groundwork for SpaceX to fully reuse their massive rocket for the first time with Mechazilla's arms in Flight 6. And if you're worried about the durability of the launch tower, Elon believes that the tower will be robust to thousands of landings. All that awaits is the readiness of the giant Starship. After securing the rocket's landing, SpaceX will aim further into space. Whether it's the moon, Mars, or any other celestial body, the heat shield engines and nose cones will play crucial roles in all these endeavors. Ahead lies a challenging journey for the SpaceX teams. Through testing, problem solving, and making significant changes, SpaceX has achieved remarkable success over the years. The same formula will continue to guide them as they pave the way for humanity's interplanetary existence. And that's all for today's episode. Thanks so much for watching, and catch you next time.